Here we have functions, trig functions, and their inverse functions in some order, one's inside of another one. We want to see how we can find their exact value. So looking at this first one, we have the tangent of the inverse tangent of -6/5, and when you have the trig function on the outside and the inverse here, they will undo each other, and that's going to leave us just -6/5. If we drew a triangle and we label it so that the tangent was -6/5 and then we took the tangent there, we'd get -6/5. Now looking here, we have inverse cotangent of the cotangent of -π3. They will undo each other if the angle is in the correct range for inverse cotangent. So let's think cotangent, the numerator is cosine, so it follows the same restrictions as cosine, which is 0 to pi, except of course with cotangent you can't equal the endpoints there because those are vertical asymptotes. Well, -π3 is right here. That is outside of that range, and so they won't just cancel each other out. We will have to find an angle that has the same cotangent as -π3 but is in our range between 0 and pi. So that would be up here where cotangent is also negative, and that looks like that's then 2π3. All right, the next one we have is the inverse tangent of the tangent of 3π4. They will cancel each other out if this is in the correct range for inverse tangent. We know inverse tangent is the right half of the circle from -π12 to π12, not counting the two endpoints where they're vertical asymptotes. So this is not going to cancel each other out. 3π4 is right here, and the tangent is negative there. The place within our range where the tangent is negative would be over here then at -π4. We have the arcsecant of the secant of -π4, so let's think about what our range is for secant. Secant's the reciprocal function for cosine, so it follows the same restriction between 0 and pi, except that there is a hole there in the middle where there's a vertical asymptote. So -π4 does not fall within that. It's right here, and that would be where the cosine is positive and therefore the secant is positive. So we need another angle that has that same x value, so that would be right here in quadrant 1. So that angle would be π4. Because secant is the reciprocal function for cosine and cosine was the x value, we need to find the one that had the same x value there. Now looking at our next one, we have the secant, so we already had actually drawn this. We want this for -π12. I'm going to just use this picture as well. So -π12 is down here, and actually that would be where a vertical asymptote was, just like there's one at π12. So this one does not exist, because at -π12 the cosine is 0, therefore the reciprocal function would be undefined. And lastly, we're looking at an inverse cosecant. Cosecant's the reciprocal function for sine, so it'll follow the same restrictions, -π12 to π12, and we have 3π4, so that's not going to work. When you get this π12 out of the way, 3π4 would be right here. Cosecant's the reciprocal function for sine. The sine is positive here, so where do we have the same value? It's the y value. That would be over here in quadrant 1. So this one would be π4.